Hello. Ah, there we go. All right, we are live on the internet. Hello, internet and people in the future. Welcome. All right, so there is homework due soon. So let's see. November 2nd, would that be Monday? Monday, yeah. So I set the 3-1 homework for Monday, the 3-2 homework for Wednesday. We're actually going to get started on 3-1 and 3-2 today, but we'll need to continue to work on it Monday to finish it up. But I wanted to scratch the surface on all of the ideas. Worksheets, let's see, where are those? Course home, workbook activities. I really liked most of the activities in the Unit 3, Chapter 3 workbook, and so I assigned a lot of them, 1, 2, 3, 4, 5, 6, and 8. This chapter covers what does it mean to add, what does it mean to subtract, how do we add, and how do we subtract. So we have what are called models and algorithms, and we're going to dive into that right now. So, magic whiteboard. Bless you. So what I'd like you to do right now is just on your own notes, write down what you believe it means to add. What does it mean to add? What is addition? How do we explain that to somebody? Write something down. Don't speak. Write first. Think, write, then speak. I don't know how many times I spoke before I thought about it. It's always bad. So just a thought. 2 plus 3 is 5, but why? Why should 2 plus 3 be 5? There's a few things we have to consider there. So for me, in order to answer that question, I have to first think of a problem that I know about. And so 2 plus 3 is 5. I believe that to be true. What does 2 mean? So we talked about 2 is a numeral, right? It's made up of a single digit. It represents an idea called number. Number means that many right there. 3, again, it's a numeral made up of one digit. It represents some idea. That idea is the number of things in that set right there. And so physically, what does addition mean? Combining, yeah. So add here means combine. Combine. I might use a different phrase like put together, synonymous with combine. And so then I end up with this new group that has all of that stuff in it. So I'm just going to redraw it for fun. I have this guy here and this short guy there. And I have these messed up blue guys, dolls, action figures. So there's my new group. Not only does it mean combine, because my brother and I used to get together to play with our dolls a lot, but we didn't usually count them. We just started playing with them. So addition not only means to combine them, but we also have to count them. So to add means to combine two groups and count up how many things you have. And so what I'm doing here is I'm modeling addition, and we call this the set model for addition. And in particular, I'm adding whole numbers here. We'll have to think later, what would it mean if they could be positive or negative? What would it mean if they could be fractions or decimals? Then we have to kind of rethink the ideas. So that's the set model. Does that seem pretty, like we all have that idea in our head? Putting it on paper might be a little challenging because it seems like, oh, like, what do you mean? What is it? 2 + 3 is 5, duh, right? We take it for granted, but it's the idea of combining and counting. All right, so any questions, comments on what you wrote down, what I wrote down? Yeah, so the addition sentence, that's just this abstract set of symbols, right? We know that these are numerals. We have to have a definition for what that particular symbol means. We need another definition for what equals means. And we've talked about that a little bit. What is the set word for equals? Anybody remember? That relates here. It also starts with an E. Equivalent, yeah. Two sets are equivalent if they have the same amount of stuff in them. So kids get used to the idea of 5 because they can count 5 candies, they have 5 fingers, they have 5 marbles, right? And all of those sets are equivalent in that they have the same number of things, okay? And so that's what there's lots of sets I could use to talk about 2 + 3 is 5. They all have the same equivalence as far as sets go, in that there's a group of 2 things here, there's another group of 2 things there. Like, who would have drawn, how would you have drawn this differently? Anybody? Would you have used stick figure action figures like me? You use dots. Dots are great. Circles, squares, right? There's lots of different things you could draw, and that's fine. Let's see. I'm not sure what else there is to say about this. What we're doing here, by the way, just a reminder, we're trying to model what it means to add, because we need to get at the understanding of what that is. Okay, and understanding comes from models. Does this help me if I wanted to add 211 plus 1,522? No, I don't want to draw that picture. Okay, that's when we need a process to get it done, and that's called an algorithm. So section 1 is about models. Section 2 is about algorithms for addition and subtraction. And algorithms are how do we do it for numerals with a lot of digits? Okay, what's the process like? Because I really don't want to draw these pictures. The pictures are helpful if I'm just getting used to what that means. The book talks about another model for addition. And they call it the number line model. And so that's where we have a number line drawn out. And by the way, can any line with marks I make be a number line? The answer is no. So this would be, the blue thing would be an okay number line, a pretty good number line. This red thing, that would be a really bad number line. So if you're a sloppy person, then I highly recommend you use graph paper. If you have a cute smartboard like I have, usually the smartboard will come with its own graph paper. So I can hit a little button and I can say, please, give me a number line, or I could tell it to give me a piece of graph paper. And so then I can draw things better. Often these things will have line tools, which makes drawing straight lines straighter, kind of thing. So you'll have to figure out your own way of doing it. Often when I'm at the whiteboard and I know I have to do a lot of graphing kind of things, I'll often have a meter stick in the room that I can use. I have a little tiny one today. It's only 1.5 feet-ish, half a meter. Because sometimes I'm not very good at drawing straight lines. Sometimes I am, kind of depends. And the other thing is not only just making the line straight, but if we're talking about number lines or graphs, we want each number to have the same distance in between if we're talking about whole numbers. Right? We can't have some crazy stuff like that red thing. Right? That's bad. Where's my tools? They are still missing. Maybe they're behind this guy. Nope. Huh, they just vanished. Come on, tools. There they are, okay. All right, so let's get rid of the bad number line. And so the number line's pretty popular. I don't know if you've been in a school lately, but most schools of early grades will sometimes have a name tag at the top of the desk, and that name tag will have a number line on it or a ruler on it. And so students will see, oops, pen, 0, 1, 2, 3, 4, 5, 6, 7. And so the number line model, yes, sir.
Class for math in first grade with the number lines. We had like a plastic laminated number line.
Mm-hmm.
You have a dice and two like board pieces.
Yeah.
And you take turns rolling dice, and for every roll of the die, you get to move and make visit the number line.
Yeah.
And whoever gets to the end of the line first wins.
Okay, so the kids are rolling their die.
Yeah.
And they're moving their piece along. Yeah. So I could roll. Cool. Let's roll a virtual. I love rolling dice. It's so much fun. I hate when that happens. I know that happened to me when I was doing the Forian math game. I kept rolling a 1. So random dice. Let's go here. So let's roll 2 dice. So I roll my 2 dice and I get a 2 and a 4. Okay. And so then on my number line, I'm going to have to move my piece. So what's the rules of the number line model? Where do I start? Are some kids going to want to start at 1? Yeah, it's the first place, right? No. So we have rules for the number line model, just like there's rules for the set model. Okay. So
one student who would count the space she was on, like say if she wanted to count, if she rolled a 2, she would count the one she was on as one of the 2.
Yes. That's another problem. Yeah, counting at where you're at. Okay, so I rolled a 2. Okay, so there's 1, there's 2. Oops, misunderstanding of what 2 means. Okay, so then I want to try and write down directions. What does the number line model mean? So, and some kids will just get it when you do it. Other kids are going to be confused and mess it up, and it just kind of depends. So then I hop once for each, say, value of the number. So if I rolled a 2, I'm going to try and illustrate again because of my dice, 2 plus 4. So I do 1, 2 hops, and that puts me here. So that's my new spot. And then I do 1, 2, 3, 4 hops. And now I can see the answer must be 6. And so I get that equivalence from my sets. Here's a set of 2. Here's a set of 4. When I put them together, I get a set of 6. Agreed? So in some teachers say the number line model is just a specialized version of the set model, where your objects, instead of being dolls or squares or dots, are spaces on a number line. Okay. This book, and I agree, it is a pretty different physical interpretation, and so I consider it a totally separate model. I agree with this author here. And then, our third step is from where we landed, we hop for each value of the next number. And then where we land is the sum, right? So to the best of your ability, write down what you think the rules are for the number line model. What are the rules? I've written down 2 of them in my words. Let me get some more chocolate here. It's a good day for chocolate. Chocolate and math. It's a good combination. Chocolate and math. And I always find when we write these out, we have to adjust our language to our audience, revise. What could I fill in the blank with here? Your landing number, the number you land on, is the sum. Nice. Yeah, it's an answer, but in particular, when we add two numbers, the answer is called a sum. Yeah. Yeah. So sum is the result of adding two numbers. Let's see, Kate, I have your in-class test here. Yeah. Okay, so that's addition. We could make addition a little bit more interesting by taking into consideration the fact that we have a base 10 number system. So somewhere I have base 10 toys over here, perhaps. And so I wonder if I can roll different kinds of dice. Let's see, where'd my random dice go? Go back. It's only going to roll a 6-sided die. I can't roll a 10-sided die. Dice roller. Ooh, oh, check that out. Dungeons and Dragons. Oh, that brings back scary memories. All right, let's get rid of that there. I think what I'll do instead is show you a new spreadsheet trick. Good job, Greg. Okay, so let's get in. Ooh, wrong class. This is Math 211. And new spreadsheet. So I don't remember if I showed this in class before, but what I'm going to do here is I'm going to go for a random digit. And Excel and Sheets and other spreadsheets have a feature called rand between. Rand between says it picks a random integer in between the two values inclusive. What does the inclusive part mean? Including the two endpoints. Yeah, like I said, give me a number between 0 and 9. It could give me 0 or 9. If it said exclusive, it would exclude the endpoints. And you got to be careful when you read what the things do. So I want a digit, which means I want something from 0 to 9. Oops, close parentheses, enter. So there's a random digit. I can grab another one. Ooh, now it's 4. It's going to keep changing every time I do something, which is kind of good, but kind of bad. 0 to 9. Okay, so I have to add the digits 6 and 8. Right. So I'm going to attempt to do that on my cute little online base 10 block thing. I found my box of base 10 blocks. I'll hand those out in just a few minutes. So I'd have to build 1, 2, 3, 4, 5, 6, 7, 8. Was that one of my numbers? I forgot now. 8 and 6, yes. And so let's put these guys together. So there's my 8. And then I have to create 6 ones to go with that. So 1, 2, 3, 4, 5, 6. Put those guys together. And so I'm done, right? I've combined them. What step did I miss?
You have to carry to the next number because you've got more than 10.
Carry? What the heck is carry? We haven't talked about carry yet. I have to, well, before I can do that, I have to count them, shouldn't I? Right, because add means combine and count. I've combined, so what? Okay, there's my answer. I'm done, teacher. Thank you very much. Can I go home now? I got to combine them. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can clearly see the answer is 14. This program has a nice feature such that if you put a group of 10 together and then you use the mouse to click and drag over them, it will put them into a 10 block. And so now I can see the answer, which is kind of fun. Cute? Okay, so I just traded in, and that's what you called carrying. Carry, you tell kids to carry it. All right, let's carry these blocks over here now, and they're gonna pick them up and, put them over there. What the heck does carry mean? Why would you carry? What are we carrying? I can't lift these numbers. They're written on a piece of paper. Isn't that a weird idea? Like, what do you mean carry? What the heck are you talking about? You're a weird man. So we'll get to that when we get to algorithms in just a minute. But picture-wise, let's all draw this together. So we're now consider our base 10 number system. I want to show what 6 plus 8 is. And this time, instead of drawing dolls, I'm just going to draw squares to the best of my artistic ability. So I have to show a group of 6. 1, 2, 3, 4, 5. And you can show them neatly arranged in a line or random. It doesn't matter at first. And then here's my group of 8. And I'm trying but failing to draw them all the same size and shape. That's not too bad. I've done worse. And then I do what addition means, which is combine and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so I can see the answer has got to be 14. And if we only do that, we're missing an opportunity. And the opportunity is to remind kids about what our number system means, what place value means. So we should pause here and say, oh, wait, couldn't we regroup one of these into a long instead of a bunch of little pieces? Right? So we could say, hey, let's grab these guys and regroup or trade in for one long. And so back to my picture over here, these guys are called longs. These are called units over here. Anybody know what the third column is called, what those shapes are called? It says it, well, they're hundreds, but what do I call the shape? Anybody remember as you read page 53 in the book? Damn, oh yeah, 53, they're called flats. Okay, so they're called flats, yeah, so they call them units, longs, and flats, and those are just big cubes. They don't have a good name for those. So we can do some trading in with these things. All right. And so now I can rephrase it. Okay, so I have a long, and my long has 10 things in it. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the best of my artistic ability. And then I have some leftover pieces. 1, oh gosh, that was a bad square. Let's try that sucker again. 1, 2, 3. And so then I can clearly see the 14 now, right? Now, are the kids going to struggle with drawing these pictures? Heck yeah. So what we want to do is we want to give them some toys to play with. Okay, so do I want to stop here? Now let's take this one step farther, and then I'll have you guys play with the toys. So I've taken the base 10, the base 10, the base 10 model, which is those base 10 blocks. So this base 10 blocks are a model for our numbers. And then I've taken the idea that addition means combine and count, and I've put them together. And what that's going to lead into is what Jared called the idea of carrying, right? Which is really regrouping physically. We're regrouping stuff. You could also call it trading in. I go to the bank and I trade in 10 dimes for $1, right? Same idea. So let's pick a more complicated one. Let's suppose we're going to start working with multi-digit numbers. So let's whip out, let's suppose I have 14 and I want to add that to 20, 1, 2, 3, 4, 5, 6, 7, 8, 28. So that shows 14 plus 28 right there. If I hit that button enough times, I think I did. And so we'll fix that in a minute. Let's go look at it over here. 14 plus 28. that like a good way to write it? How will it be written in the book? Well, it'll probably be written some of the time like this, 14 plus 28. More than half the time kids saw problems before with single digits, they were often written like this. Okay. Sometimes the books start introducing the stacking way of writing it, which the kids have to get used to. So you got to pay attention. Which way did we show this? Because if this is a whole new shock for them, because everything else they saw was this, then you have a whole new ball of trouble on your hands.
I see a lot, they'll write, instead of writing the little line, they'll bring it up here and stick it there. For some reason. I don't know.
Oh.
I've seen it repeatedly.
Yeah, okay.
Among different students. I don't
Yeah.
know if that is borrowing from their neighbors or what.
Yeah, yeah. There's a lot of weird stuff because, you know, how many times have you said something to somebody and they did not hear what you meant, right? That happens a lot. So let's see, let's do this. So if I were a kid and this was new to me, I'd be thinking 4 plus 8 is 12. I got that down. Well, I didn't miss anything yet. I'm not done. 4 plus 8 is 12, is it not? Okay. All right, what do I got right here? Oops, right there. No, that's, what are you talking about? That's a 10 as far as I know. My teacher told me that that's the tens place. So that's a 10. What's this thing right here? 10 and 20. Let me get my toys out. So I go to my toys over here. Let's see, 10 and 20. Oh, that's 30. I know that. Right? 1, 2, 3, 10, 20, 30. Totally down with this. That's 30. Oh, I'm not quite done. 2 and nothing is 2. 10 and 30 is 40. So the answer's got to be 42. Did I do it right?
I was never taught that way.
I'm not saying teach it this way. I'm just saying, hey, did I do it right? Okay, let's do that again for a different one. Let's try 26 and, I don't know, 17. What's 7 plus 6? 13 on a good day? Okay, 13, man, that's how I used to write 7 plus 6. Why should I stop? And then that's, I know my place value. That is a 20, darn it, and that is a 10. What's 10 and 20? 30. I'll tell you right, 30, isn't it? Are my place values lined up? I'm rocking. I'm not quite done because 13 and 30 is going to add up to 43. Okay. Now, you're thinking, that's not the way I was taught. And I heard you say it a second ago, some of you. You were taught to take 26 plus 17 and say, let's see, 6 and 7 is 13. So put the 3 in there and the 110 up there. But you didn't say 110. You just called it a 1. And we just put it in that column because my teacher said so. And then 1 and 2 is 3 plus 1 is 4. Is there any concept of place value there, or can we do it without understanding place value at all? As long as I put things where my teacher told me, I don't need to know crap about place value here. Could this lead to misunderstandings? Yes. 13. Say 13 for me. When you say 13, I hear the 3 in that first. And so I might accidentally do that. 13. There's my 13. And then I'm screwed at that point. So this is called the regrouping algorithm. What you believe you grew up with. Anybody know what algorithm means? It's a set of instructions. Yeah, that's all it is. A procedure, you could call it. Yeah, algorithm is just a set of instructions. And the instructions are add the ones. If it adds up to more than 10, put the 10 digit in the tens column. Now add up all the digits in the tens column. That might lead to another carrying, but carrying, why do we call it carrying? We carried over to place value, okay. Yeah, so I physically picked it up and move it. How about regrouping? Yeah, so that makes physically more sense, right? Regrouping makes physically more sense than the word carrying does, I think. Carrying, yeah, just put it there, just carry it there. Why? Because my teacher said so, that's why. Right? And we don't want to have kids do things just because we tell them to. We want them to try and understand why. Will everybody understand why? No, there are tons of math I've done and worked with kids. They got how down. Why? Pfft, not yet. Maybe next year, maybe the year after they'll get why. But we can't stop pushing it. We need to keep pushing it. And some kids will get it right away. Some kids will get it next year. Some kids will get it that year after. But we got to keep trying with the why. Do we want them to explain why? That's pushing it. That's pushing it. You'll see some, it depends on the grade level, yeah, and you'll see some of the videos that I've included in the homework. They'll ask kids, well, why did you do that? Why should you put it there? And sometimes the kid, after repeated questions, will say something, oh, because place value, it's a group of 10, it goes in that column, right? And they're like, whoa, wow, you really got that, which is pretty neat. This right here works, doesn't it? It's an algorithm, it's a process. This is called the expanded algorithm for addition. And you will see this in some books. Yes, right. You could write it out that way too. Yeah. So what Morgan said, could you write it as 20 plus 6 plus 10 plus 7? Yeah, and then we can say, okay, yeah, 20 and 10 is 30, 6 and 7 is 13, 13 and 30 is 43. Yeah, so there's lots of ways to write it. I like the stacking way of writing it as opposed to the spread out way. Some kids are capable of doing this, others maybe not. You will see this in some workbooks and textbooks in the elementary schools, either this way and or this way here. You will see that come up as a lead-in to this algorithm. I like this algorithm because it's very efficient. I don't have to use a lot of ink. This one uses more ink, but it gets at the idea of place value. And what's more important, getting a good grasp of place value or just learning a procedure that works? They're both important, but I think understanding place value is something we need to keep pushing, keep pushing. So we don't have like people mistaking a billion for a million, right? Or a billion for a trillion. That's a problem. All right, I'll show you one more cute algorithm and then I'm gonna do a new recording in a minute after I give you some toys. Let's see, oh gosh, I have all this extra shit. This is called the lattice algorithm. For addition. And this is quite cute. So we'd write, say, our 26 plus 17 as usual, and then underneath what we do is we make a rectangle, and then we split the rectangle in a column for the ones and tens, and we make diagonals from the upper right to the lower left. So I come down like that. And then I say, what is 6 plus 7? 13, and so 13 just kind of fits really nice like that. And then over here I say, that's not 2 plus 1, what is it really? It's 20 plus 10, and 20 plus 10 is 30. Uh-oh, I made a mistake. What did I do wrong? Oh shit, no, I lied. Yeah, no, that 10 thing is in the wrong spot. I just have to think about the place value. I don't have to write the 30 part. Excuse me. So this is 2 10s and 1 10. It does work a little different. 2 10s and 1 10 is 3 10s. Because I got to take into consideration if that was like 80 and 90, 8 and 9 10s would be 17 10s. right? And I got to be ready for that. So the 3 10s has to go like that. And then what I do is I just follow the diagonal. There's only one thing in this diagonal, that's a 3. There's 2 things in that diagonal, and the 3 and the 1 give me a 4, and so there's my 43. Okay. So since I messed it up the first time, let's try it on a different, bigger set of numbers. And again, these are algorithms. Algorithms don't necessarily go into why the answer is what it is, it's just how to get an answer. We don't really care about why necessarily. So let's suppose we had 387 plus 295, for example. So what we would do is we would make our grid, splitting up a box for each place value, and then we come down, and we don't even have to think about place value, we just think about adding the digits that line up. So 7 and 5 is 12, and 8 and 9 is 17, and 3 and 2 is 5. And then we follow diagonals. 2, 7 and 1 is 8, 5 and 1 is 6, so the answer should be 682. Okay, I did it right that time. Whew. Isn't that cute? All right, so I'm going to pause this recording. I'll come back with some more stuff on subtraction in a few minutes. Those of you out there in the internet or in the future, stop.